Hey guys, welcome back. So in the last video we talked about how to delete a node from a circular double linked list. Hope the concept was clear. Now in this video, let's talk about how to delete the entire circular double linked list. So before understanding how to delete a complete linked list, we should always keep in mind one thing, that is, garbage collector will only delete those nodes which are not being referenced by any reference variable. So in this case, if we want to delete this entire list, we have to follow some steps. First of all, we have to make sure the last node is no more referencing to node 1. So we make it null. Now once this is done, this connection over here gets destroyed. Now the second step is we have to make sure that each node's previous reference is also made as null. So in node 1 the previous reference is 333. In node 2 the previous reference is 001. In node 3 previous reference is 111. In node 4 the previous reference is 222. So all of this needs to be made as null. Now once this is done, all that we have to do is make head as null and tail as null. So doing this will make sure that the linked list gets eligible for garbage collection and system deletes it. Now let's see why system will delete it. Let's come to node 1. Is this being referred by any reference? Remember, from node 4 to node 1, this connection we have already destroyed. Head to node 1, this we have already destroyed. Node 2, node 1, this we have already destroyed. Remember, the previous reference has been made to null. So node 1 is now not being pointed by any reference. So garbage collector can delete it. Once this is deleted, let's see if node 2 can be deleted or not. Is node 2 being referred by any reference? It was initially by node 1, but since node 1 is no more, so node 1 is not referencing it. On the other side, node 3 was referencing it, but we made sure that the previous reference, this is set as null. So node 3 is not pointing to node 2. So node 2 is basically not being pointed by either node 1 or node 2. Hence it gets eligible for garbage collector. Similarly, node 3 is not being pointed by node 4 because we deleted this connection. Node 2 is already deleted, so no question of this connection over here. So node 3 can be deleted. Similarly, node 4 can also be deleted because this connection over here with the tail reference is not there anymore and node 1 is not there anymore, so no question of referencing from node 1 to node 4. So I hope you have understood how to delete the entire circular double linked list. Now let's see how does the algorithm looks like. So the algorithm is extremely simple. The name of the method is delete linked list. It takes head and tail references. Now first of all it does is tail.next is equal to null. What is tail.next? Tail is 333. So tail.next becomes this reference here. So right now it is 001. We make it null. So this way we disconnect this connection. Then we are running a loop from head to tail and making sure that the previous reference is always set as null. Now what is previous reference of node 1? It is this reference here. What is previous reference of node 2? This reference here. What is previous reference of node 3? It is here. What is previous reference of node 4? It is this. So all of these 4 references are set to null. Once that is done, we say head is equal to tail is equal to null. So we make this and this as null. Essentially, we are destroying all these connections. So I hope you have understood how does the algorithm works. Now let's see what is the time and space complexity of this algorithm. So setting a reference variable will take order of 1 time. Running a loop from head to tail will take order of n time. Again, setting a value in a reference variable is a constant time operation. Similarly, setting head and tail as null is a constant time operation. So if we add up all of this, we get time complexity of order of n. Now the space complexity is order of 1 because we are using some temporary variables here and there, but they are not in proportion to the size of the list. Hence the space complexity becomes order of 1. So I hope you have understood how to delete the entire circular double linked list. Now with this we come to end of this video. In the next video, let's recap all the time and space complexities that we have seen for all the 6 operations that were performed on circular double linked list. Thanks for your time. See you in the next video.